Alright, guys. Yeah. So last time, we did number 1, number 2, number 3. Now we're gonna do number 4, number 5. Continue again. So, sorry. So when you read this question, they say that the sum to infinity of a geometric series with positive terms is that. Ne? So sometimes from reading these questions, there are clues there. They're already telling us that there's a sum to infinity. Therefore, we know our series converges, and we also know that r it's going to be between -1 and it's between -1 and 1, right? Because if a series converges, r must be between 1 and -1, right? Cool. So we also know that sum to infinity equals to a it's a over 1 minus r, right? And they're telling us that it is equals to 4 1 over 6, right? And yeah, this 4 1 over 6 shift 4 1 over 6, just want to write it in as a fraction, not a whole number. Yeah, I want to write it as just a fraction, not a whole number, not a mixed fraction. Yes, is it called the mixed fraction? I think this was about grade 8 or 9, talking about different types of fraction. But if you say you don't have your calculator, if you don't have your calculator, this is how you can neatly do it. This number is the same as 4 plus 1 over 6, right? Which is the same as 4 over 1 plus 1 over 6, right? You see the denominators are not the same, so we make them be the same by multiplying by 6 over 6, then 1 over 6. Here, 4 and 6 multiplied, 24 over 6 plus 1 over 6, which is 25 over 6. You see, 25 over 6, 25 over 6. That's how it's done. Yeah, that's if, say for example, sometimes you find out your calculator has been stolen and there's nothing you can do to recover it, and no one has an extra calculator. This is how you would survive. And then here, what? Okay, cool. Here, what I want to do is let me write a as a subject of the formula, right? So that will be, to write a in fact as a subject of the formula here, I'll have to multiply by 1. I'll have to multiply by 1 minus r. Yeah, so 1 minus r this side, it's going to cancel 1 minus r. And then we have 25 over 6 into 1 minus r, right? Cool. Let's go back and read. The sum of the first two terms, right, is that, and we have to find a and r, right? Cool. So they told us that the sum of the first two, that is S2, which is T1 plus T2, right? So now when we're talking about a geometric series, remember we have Tn equals to a multiplied by r to the power of n minus 1, right? That's the formula we use. And yeah, so for T1, we just come here and say a to the power of r 1 minus 1, right? Which this 1 minus 1 becomes 0. Anything to the power of 0 is 1, so you have a. So that means, okay, we didn't finish it here. It's 2 over 3. So that means here we have a, right? And then if for T2, right, for T2, you go here and say 2, you substitute 2, then you get a r to the power of 1, because 2 minus 1 is 1. So here you have a r, right? And then we can do our thing here with the calculator. You have 2 over 3. That is 8 over 3. Let me now take out a 1 plus r equals to 8 over 3. And so now let me call this equation 1 and let me call this equation 2. Right, it's a bit messy now, but maybe let me remove this. Equation 1 and equation 2. Just in case we might need some more space. So now we're going to substitute equation 1 into equation 2. Right, 1 into 2. So we have a equals to this, and we have a here. So we do that. Where we see a, we put 25 over 6, 1 minus r, 1 plus r, and then you have 8 over 3. Right, so yeah, usually when you have such things, you want to get rid of your denominators, né? And one possible way, both of these, they have a factor of 3. In fact, that's the highest common factor between 3 and 6. It's 3. So if I multiply by 3, I know this denominator will be gone. But remember now, when you want to get rid of these denominators, you don't multiply by a highest common denominator. You multiply by lowest common multiple. So lowest common multiple is 6, because you have 6, 12, 18, and then you have 3, 6, 9. So 6 is the lowest common multiple. So we multiply by 6, right? When we multiply by 6, this 6 is going to cancel the 6, so you have 25, né? Cool, open bracket. Now just a little bit, let's focus on the brackets. What do you see? Just remember factorization and so forth and so forth. So because you would remember this thing called difference of two squares. When you have difference of two squares, it's easy to factorize them because there are two brackets. It's going to be exactly the same thing. Yeah, the two brackets is going to be exactly the same thing. The only thing that is going to be different is the sign. On one bracket you have a positive, on the other you have a negative, but other than that everything is the same. That is what we have here. So that means here is going to be 1 minus r squared. You see, and knowing that, it helps you also avoid this thing of FOIL. You know, now you're multiplying 1 times 1, 1 times r, minus r times 1, minus r times, it avoids all of that work. Now the 6, this side is going to be, we have our 8. So here when 6 multiplied by 1 over 3, the 3 is going to be gone, and then here you will just have 2, so we can say multiply by 2. Right, so that means you have 25 minus 25 r squared equals to 16. Right, and then let me say 25 minus 16 equals to 25 r squared. I believe that is 9. 25 minus 16, that is 9. So 25 r squared. Right, so yeah, let me do this. Here I can just put square root both sides, which I would still, yeah, I can put square root both sides, or perhaps I could divide by 25 both sides and then put a square root both sides. That will still be fine, right? But I saw something interesting here, 5r squared, because 5 squared 25, r squared minus 9, but 9, let me just say that is 3 squared. What do you see? Difference of two squares, né? So now with difference of two squares, we do exactly what we just spoken about right now. What we have just spoken about, it's 5r minus 3, first bracket, 5r plus 3, second bracket, and you're done, right? So you know that you're gonna have what are you going to have? Oh, therefore 0 equals to 5r minus 3, or 0 equals to 5r plus 3. Here 3r, and therefore r is equals to 3 over 5. Here you're going to have minus 3, 5r, and then r is going to be minus 3 over 5, right? Cool. Now I ask a question. Is there anything on, or any clue that, is there anything that hints us as to are we going to use both these r's to find the a, or are we going to use one of them? And when you read the question carefully, you would see that they said our series, it has positive terms, right? So for our series to have positive terms, it means that we must always multiply, like, okay, if r, remember r, we multiply the current term by r to get the next term. So if r is negative, right, if r is negative, there is no way that our term values will always be positive. Like, there's no way we're going to have positive terms, right? They will alternate positive, negative, positive, negative. But then when we have an r that is positive, we can be very sure that I bet are we going to have positive terms, right? Unless, of course, the what is this thing? I mean, no, there's no unless, bro. No, okay, let me say unless the first terms of your series, right, or your sequence, they were negative, right? So regardless us having a positive r, when we multiply those negative terms by a positive, right, r, we're going to get another negative term, right? So yeah. Yes. But no, bro. No. When I think about this thing, it doesn't make sense. It doesn't make sense. I don't think there's a situation where, yeah. But it's okay. It's fine. We are very sure that the negative r cannot work because it's going to give us negative terms, and here the series has positive terms, right? So we can use this formula that says a equals to 25 over 6, 1 minus r. So that means we have 25 over 6, 1 minus 3 over 5. One minus 3 over 5. And we are getting the answer 5 over 3. Right, and just like that, friends, these are the answer we are looking for. All right, cool. It took me the whole 13 minutes on this problem. Here's an interesting one. So use the sum to infinity to show that, right, 0.9 recurring equals to 1. Right. So remember, let me use rate. Remember, 0.9, right, with a dot is 0.9999. Bro, it continues, ne? That's what recurring means, ne? Let me just put a dot on top there, right? It continues, right? It does continue, ne? Oh, by the way, let me show you something. 0.9. this is 0.9, ne? This is 0.99, 0.999, 0.99999. Do you see what's happening? But just hold on. I believe, look at this. I can say 0.9 recurring is equals to 0.9 plus 0.09 plus 0.009 plus 0.0009, right? Plus, right? And the reason, look, 0.9 plus 0.09. Do you remember? Okay, cool. Plus 0.009. Do you see? Plus 0.0009. Do you see what's happening? I think the last number we did was like this. Do you see what's happening? Yeah. And now when we convert these, 0.9 is 1 over 10, right? This one, it's 9 over 10, and this one is 9 over 100. This one, 9 over 1,000. This one, 9 over 10,000. Right? And they continue like that. So right here, I think I low-key have answered the question, because this was the tricky part. When you look at this question, you wonder, hey, how are you gonna attack it? Like, what's going on? But I think with this, because now you can see, bad, we have a series there. And that series, let me do this. So this is T1, T2, T3, T4, right? Let's find out. T2 over T1 is going to be 900 divided by 9 over 10, which is 9 over 100, multiplied by 10 over 9, and then the 9 cancel, and then this cancel, so you have 1 over 10. Let's do T3 over T2. You have 9,000 divided by 900. 9,109. So of course the 9 they cancel, and then the 100 cancels. So you're gonna have 1 over 10, right? So therefore R equals to 1 over 10, and what? And A equals to what is A? A is 9. Let me just say 0.9. So 0.9 is the value of A, right? From here, then you say S to infinity equals to A over 1 over R, which is equals to 0.9 divided by 1 minus R, which is 1 over 10, right? So this is 10 over 10, 9 over 10, 0.9 divided by 0.9, right? And just like that, bro, we are done. This question, I think I would give it 3 marks. I don't know, maybe, I think I would give it a 3 mark. I think it's a 3 mark question. But also, like, if you haven't done questions like this, you would struggle. You would really struggle. No matter what you do, you won't get the answer. Cool. I think this is the last, and then I have, what do I have here? We have this gentleman on the left hand side and the gentleman on the right hand side. Remember, these are sigma notations, Cool. And we have to find the P, right? We have to find the P. Cool. Oh, beautiful. So this question, if you don't know what you are doing, it's gonna get tricky, right? It's gonna get tricky. I'm gonna handle it step by step, Left hand side. right? um yeah, yeah. So basically here I'm trying to find or not, we are not trying to find, but that is what they are having on that side. No, that is what they are having that side. And from this side, from the right hand side, you can tell that we're going to get our number. We're going to know exactly, we're going to know the value this side. And after knowing the value this side, that then says that this series, it has a sum to infinity, and therefore you would use that formula of s to infinity equals to a over 1 minus r. Right, we will come to that. Let's just pause and focus on the right hand side. Right hand side. So the right hand side, you have that sum. Before I write that sum, I don't want to write it even, but I want to focus on 24 minus 3, right? 24 minus 3t, right? This is an arithmetic sequence, right? It is an arithmetic sequence. And then as for arithmetic sequence, you remember that Sn equals to n over 2, right? Yeah, is it 2 over n or n over 2? I think it's n over 2. And then this side you have 2a plus n minus 1 d. Yeah, let me just check with my sources here. I'm not sure if it's n over or what. Yeah, we nailed it. It is. So that means from here, I need to find a couple of things. I know n is going to be what? It's going to be 12 because we're adding from 1 up to 12, right? So I can say for n, check. I need a and I need d. But d, I don't have to struggle because I know d is what? Minus 3. Ne? Minus 3. So now I just need to find a. And to find a, I'll just say 24 minus 3, 1. Right, that is 24 minus 3, 21. Yeah, minus 3, just 21. Cool. So let me say equals to a. So now I say therefore S12 equals to 12 over 2 times 21 plus 12 minus 1 minus 3. Times 21 plus, let me say minus because of this minus, you get me? So minus 3 into 12 minus 1, right? So yeah, so it's 12 divided by our gentleman over there, yeah, which is 2, and then we have 2 times a, right? 2a, so a is 21, and then it's this minus and positive minus, so minus 3 into 12 minus 1, then close, right? And we are getting how much? We are getting 54, right? 54. So therefore yeah, therefore that sum 12 t equals to 1, t equals to 1, 24 minus 3t equals to 54. You see? And then we can therefore then say, right, we have left hand side equals to right hand side, which is what? The left hand side, remember, the left hand side you have this k equals to 1, then 27p to the power of k. E 54. Anne? Cool. So we did say that there's what did we say? We did say that we're going to use this formula. No? For this formula you need A and you need R, right? So for A, I will substitute. So you would just say T1 equals to 27. We're trying to find P, so we don't know what P is. And then for K, you substitute 1. Okay? And then this is A that you need. And then you also need R, right? You also need R. So we can just find 22, which is 27p 27p squared, right? And then from these two you would then say t2 over t1 27p squared 27p is p, which is r, né? So that means you have 54, because that is the sum to infinity of this 54, then A, that is 27p, then 1 minus r, which is p. Yeah. And then I can say I have over 1, cross multiply, therefore you have 27p equals to 54 minus 54p, right? So that is 27p plus 54p being 54. Yeah, let me write it properly. 27p minus 50 plus 54p 54 27 plus 54. So 27 plus 54 is going to be how much? There we go, 51p. We divide by 51, divide by 51. Yeah, I was shocked. 2754. Yeah, I was shocked, bro. Because already I'm calculating, I'm like, but no, this is going to be above 1. And it cannot be because we have a converging. Yeah. So yeah, we divide by 81, divide by 81. P equals to 54 over 81, right? Which you don't have to do this, right? Oh, nice. We can even 2 over 3, right? Which is 0.67, right? And by this you see that, okay, your R is between 1 and -1, therefore the series that you have must be a converging series, and we did find P, so we are good. That'll be the end of this video. Thank you so much Oh, by the way, don't forget to subscribe if you haven't.